This is Dr. V. Maria Antoinette Martin, Assistant Professor, Department of Information Technology, St. Joseph's College, Trichirappalli. In this session, we are going to discuss about linked list in data structures. Content. Introduction to linked list. What is node? Representation of linked list in memory. Traversing a linked list. Introduction to linked list. A linked list is a dynamic linear data structure. This means the size of the list can grow during program execution. A linked list is made up of nodes, and each node is connected to the next one using a pointer. The pointer simply stores the address of the next node. One big advantage of a linked list is that it is very suitable for frequent insertion and deletions. We can easily add or remove nodes using without shifting other elements, unlike an array. Another important point is that a linked list does not require contiguous memory. Each node can be stored anywhere in memory and pointers link them together. What is a node? This diagram shows the basic structure of a node used in linked list. A node is divided into two parts. The first part is the data field. The second part is the pointer field. A node is a basic unit used in linked list data structures like linked list and trees. Each node has two important parts. The first part is the data. This is the actual value stored in the node, such as a number, a name, or any other information. The second part is the pointer, also called a reference. This pointer stores the address of the next node. It helps connect one node to another, forming a chain. Representation of linked list in memory. In a linked list, nodes are stored in random memory locations. This means they are not placed next to each other like elements in an array. Each node contains two parts, a data field and pointer field. The data field stores the actual value and the pointer stores the address of the next node. Even though the nodes are scattered in different places in memory, they are connected logically through these pointer addresses. A linked list is different from an array because it is not stored in contiguous or continuous memory locations. Instead of sitting next to each other in memory, the elements called nodes can be stored anywhere in the computer's memory. What keeps them connected is a pointer inside each node. This pointer stores the address of the next node, allowing the list to form a logical chain even though the nodes are stored in random memory locations. Now let's look at the memory structure of a node in a linked list. Every node is divided into two parts. The first part is the data field. This is where the actual value is stored. For example, numbers like 10 or 25 or even text like hello. The second part is the pointer field. This pointer doesn't store data. Instead, it stores the memory address of the next node in the list. Using this address, each node knows where the next node is located, even though the nodes may be stored in different locations in memory. In a linked list, the nodes are stored randomly in memory. This means each node can be placed at a different memory address, not one after another, like in an array. Even though the nodes are not stored consecutively, they are still connected. How? Through the pointer field inside each node. The pointer of one node stores the address of the next node, and this creates a logical chain. In a linked list, we begin accessing the entire structure using a special pointer called head. The head pointer stores the memory address of the very first node in the list. From this first node, we follow the pointer to reach the next node and then continue to follow pointers until we reach the end of the list. So the structure looks like this. Head points to the first node, which points to the next node, and this continues until we finally reach null, which indicates the end of the linked list. Think of the computer's memory as a large collection of addresses. For example, you might have memory locations like 1000, 2000, 3500, 4500, and 6200. In a linked list, the nodes are stored at any available memory address. So, node A might be at address 1000, node B at 4500, and node C at 6200. They are not stored next to each other. Even though the nodes are scattered, they stay connected because each node stores a pointer to the next node. So, node A pointer contains the address 4500, which leads to node B, and node B points to node C at 6200. Finally, node C points to null, which means it's the end of the list. A linked list uses dynamic memory allocation, which means memory is created only when we actually need a new node. For example, in C program, we use functions like malloc function to allocate memory during runtime. This is different from arrays where we must decide the size in advance. With linked list, we don't have to predefine the size. The list can grow whenever we want. This makes linked list very flexible, especially when the amount of data keeps changing. Traversing a linked list. Traversing a linked list means visiting every node of the list one by one to access or process the data stored in each node. It is one of the most basic operations performed on a linked list. We perform traversal whenever we need to visit each element one by one. First, traversal is needed to display all elements. Second, we use traversal to search for a value. Third, traversal helps to count the number of nodes. Finally, traversal is required for operations like insertion, deletion, or updating at specific positions. Now, let's look at the steps to traverse a linked list. First, we start at the head pointer. The head stores the address of the very first node in the list. Next, we create a temporary pointer, often named temp or current. We set this pointer to the head using the statement temp equal to head. Then we visit each node one by one. At each step, we can access or print the data inside the node using the temp implies data. After processing the current node, we move to the next node. This is done by updating the pointer temp equal to temp implies next. We continue this process until the pointer becomes null. When temp becomes null, it means we have reached the end of the linked list and the traversal stops. Let's understand the traversal logic of a linked list. A typical linked list looks like this. Head implies node 1 implies node 2 implies node 3 implies null. Traversal moves through the list step by step. First, we visit node 1 because the head points to it. Then we move to node 2. Next, we visit node 2 and again move to node 3. Then we visit node 3. After node 3, the next pointer becomes null, which means there are no more nodes. So when we reach null, we stop the traversal. This is the basic flow of how traversal works in a linked list. Thank you for your patient listening.